Yo, yo, yo. What's up, Peach? Hope you had a wonderful weekend. And hope you're ready for a new week of Terrain Generation. Because that's what I'm going to stream. And I thought it would be a good idea to I just noticed that in my issue here concerning custom terrain solution, I've missed writing up some tasks and some notes, so I thought it would be a good idea to just start today by summarizing last week, but in a nice implementation notes way, so it can be used later on if and when and if I want to make a video about this topic. A Bing Fallout yesterday, good stuff. Oh, nice. Nice. Yeah, I've been meaning to watch that. since like last Friday or something like that. But okay. Cartoon, what's up? How's it going? It's going pretty good. Just started the stream, trying to get back to where we left off this Friday. And it's morning here. How are you doing? What's up, Minima? How are you doing? So, I think it was actually quite a productive quite a productive week last week. And I learned a lot. So, implement simple terrain generation. This one is done. What we're working on now is or what we started to work on last week. Implement instanced GPU driven. I don't even know. GPU based sounds better. Terrain generation. Oh yeah. Not too bad, getting close to finals for university, so I'm on the stressed side. Yeah, I can relate. Good luck with the finals though. Good luck. So, implementation notes here. Let's see here. General implementation. We actually have we have done this in 2 ways. We've actually done it in 3 ways, but I don't really want to call terrain instance here. I don't want to, like, it was one separate short adventure, but unfortunately it didn't leave us with enough customization, so we can't work with that one. Good morning, Geralt. Hope you had a wonderful weekend. Yeah, so it's basic, actually vanilla terrain generation. Basic implementation using actually in terrain base and terrain patch using Unity components, mesh filter and mesh renderer. And I mean, like, this solution worked. And for our use case, I think it was good enough performance, basically. But it can always be better. And but it's nice to know that if this terrain base using, like, we're pretty much using this call right here is like the basis of this approach. So it's generating one mesh and then render it on multiple places based on some properties here. And it's like you send a lot of data to the GPU, which you would otherwise as well, but like here we pack it into we pack it into arrays, so we don't set one texture, we set a terrain texture array and a matrix array. And then we use instance IDs to fetch the correct variables. I think it's a pretty cool solution. But then again, it feels good to have this solution to revert back to if the other one would fail. I don't think it will, or I'm gonna make my best to not let it fail. But yeah. Terrain generation using based on instancing and graphics methods. I don't know. Actually, this is more, should probably be this like content of this, not, let's see here, terrain generation, instance based terrain generation based on instancing and the graphics. And let's see here. I just wanted to get this down on paper. Good to have. And hopefully like extend these sections a bit more as we go. So what we're gonna do today is we're gonna try and implement connected vertex neighbors. Maybe not the best name, but connected vertex neighbor normal generation. So the idea is that you calculate the normals by comparing to each connected vertex neighbor. In fact, I want to have figures here as well, but what is it? Draw.io, that is the standard still. Would be really nice with some figures. But yeah, so we have this approach implemented in the vanilla terrain generation, and this one gives the exact same result, I would say, except for the edges, as Unity's mesh.redraw recalculate normals. Actually, let's put that into a note as well. This approach yields Unity's mesh dot let's put those. So this is what we're gonna do today, and this is going to be a little bit messy compared to this pretty straightforward way of the old implementation. So this here we have terrain patch, the classical one, and here we just have a method calculate normal from height. So we get the terrain patch we need to get the correct data. So this can be this terrain patch or its neighbors, and then we get the height value we want, and then we calculate it like this. And like this works here because each terrain patch is its own object with its own data on the CPU and on the GPU. Now, when we work with instanced meshes, each terrain patch is actually like the same mesh, and the difference between them are done on the GPU, which means that we're gonna have to calculate normals on the GPU, or we calculate them on the CPU, or part of them on the CPU, save them in a texture, send it to the GPU, and fetch it from the texture instead. I know I talked a bit about this last Friday, so it's like if you want to calculate normals on the GPU, you're gonna need what is it? 6 texture reads. And I'm not sure we want to do that every frame in the shader. Instead, we just do it as soon as the but then again, nah, we're gonna do it on the CPU, because you don't want to do 6 texture reads per normal per patch every frame. So as soon as we change the terrain, the player changes the terrain, we apply the changes and recalculate the textures. So that's the height map, and if we recalculate the height map, we also recalculate the normal map. But it's also the old problem of how communication between terrain patches are done, because like this implementation here, I'm not a big fan of it. But yeah, I guess it's nothing more than to just get started. So it's terrain patch indirect, and terrain base indirect we're gonna sit in a lot. Oh yeah, and we added this one last Friday. Okay, so maybe a first good thing that we need to do is just play and see what kind of result we have right now. See if it even works. You know, Monday mornings. Usual Monday morning stuff. Yeah, so we create terrain patches here, and we add some data to it, and here we pretty much just like we have a set of data textures, and we just loop through them and give them to the terrain patches just to try some things out. Each terrain patch will have its own texture eventually. Then we set up the neighbors as well in this rough way, and then the idea is to do, when we have the neighbors set up and the terrain patches set up, then we recalculate normals. Oh yeah. Okay, so we're gonna try this recalculate normals naive. but I just want to see where we're at first. Get the normals to work with a naive approach, and then we can improve it. Yes, okay, so it might not look as much, but that's pretty cool actually. Terrain based on one mesh, but different height maps. We don't have any stitching as well, as we can see here. We need to fix that as well. But I want to fix the normals first, so let's go for that. And the naive approach is we get, first of all, we can notice that we go from 1 to width -1 in both dimensions or directions, and we just take down minus, or left minus right, and that would be the normal in the X direction, and then down minus up, and then we normalize this and we change it from -1 and 1 to 0 and 1 to better be able to pack it into a normal texture. And yeah, let's see what happens with this. So thanks to this one, each patch now has a terrain and normal texture. Maybe we want to create this one with some additional settings actually. Not experimental, but here, MIP chain linear. We want this linear to be true, otherwise it gets stored as non-linear. So it gets stored as sRGB, and I always forget if it's the lower color values that are represented by more bits, or if it's the higher linear color values that are represented by more bits. But yeah, texture format. RGBA float. Like, it's a normal texture. We probably don't need the alpha channel, but I'm gonna keep it there for now, because we will see down the road if, like, what it all comes down to is how many texture channels are we actually gonna need to represent everything we want to represent on the GPU. And game logically, like terrain data texture right now, it's a grayscale, or it's actually a red scale, because we only use the red channel, and we use the red channel to store height data. But in the future we're probably gonna use maybe the other channels for something else, so like navigation data, very simple collision, like we might have pixels that are occupied by something that should not be traversable, and we can mark that with some channel and so on. And so it all comes down to, do we want something in this alpha channel or not? Maybe we do. MIP chain false, and then last linear false. So now we have this normal texture here. We put it like this, or we calculate it like this, and we set the pixel. Also we use set pixel here, which is not the quickest one. We're gonna change that to set pixel data or set pixels. So then in terrain base indirect, we need to do something similar to this with the normal as well. So we can start by actually, in terrain shader indirect, we can start by adding one more of these. So Unity declare text to the array, terrain normal texture. We have max height here. I also want actually I set vector here, but we don't actually have it in the shader yet. We want this value as well because we're gonna use it eventually. We're gonna need the delta values to properly scale the normals, or tilt them, one could say. So yeah, okay, I named it delta here. So let's see, we don't have it here, right? We don't have any properties up here, we just have variables like this, so that's good. Still evaluate uniform. Do we really need / want it? I have no idea. But we do want a float. I think we're gonna have to do it as a float 4. Maybe float, let's do float 2 delta, which should correspond to this one. Terrain normal texture. Yeah, we don't even have any. Okay, let's just see if we can. First we okay, let me put this into tasks. So this one is done. Implement okay, so if we get per instance normal map generated using naive approach, then we do implement basic we're gonna do blin fong light calculations. This is also going to be a little bit of a problem because we're gonna have to do a little bit of a different approach compared to what I'm used with. So I'm not used to working with shaders in Unity using CG program, and including this one, unfortunately we do most likely need it because of this. So to properly work with instancing and stuff like that, we need to work with this instead of HLSL program, which means that I can't include the functionality I usually use. So yeah, it's gonna be a little bit of an adventure, see how we can get, we want to fetch light data and stuff like that, but in with Unity CG. Yeah. So implement basic Blinn Phong light calculations, and when we have that in place, we want to implement per instance normal map generated using connected neighbors approach. Yes, and when we have that in place, we want to do the implement terrain patch indirect. Patch communication. Yeah, I think this feels correct. So let's see here. Set texture terrain data texture. So yeah, we want one of these for loops again. (2D array). Yeah, this is also a pretty rough way to do it. Actually, let's do it like this. We need to fix this definitely in the future. But let's create this one here as well. And I wonder, width, height, length. Yeah, we're gonna do all of this. And its MIP chain we set to false. Hopefully linear false. Beautiful. Yeah, we definitely want linear false here as well. And then we do terrain normals array set pixels. Yeah, basically exactly the same as here, but normal terrain normal texture get pixels. So each patch. Fuck, I wonder if we can do this in a better way in the future. Nah, it should be okay. Yeah, we just need to do this once, I think. So, like, we pretty much link it. Yeah, I think this... Yeah, okay. Fuck. Yeah, we want to save these variables later on, because yeah, so what we do here is we take the data we have in these 2D textures and we copy it over to these 3D textures. We don't actually have... So these don't actually hold references to the 2D textures, which means that every time we change a 2D texture, we need to do this as well. So this needs to be reworked in some way. We could continue having it like this, save these up here, as properties. So I wonder though, let's see, I just need to double check this one, like if it would be nice if it had some form of reference approach. Ooh. Okay, so these are static. Yes. Yeah, so this. Like the best approach forward would probably be to just have texture 2D array. And skip having this one basically, but like skip having each terrain patch hold its own terrain data and terrain normal texture. So optimize it by going away from this more object-oriented approach. Maybe. Maybe. Yeah, that's probably what we're gonna have to do. But fuck, I'm not... Yeah, in some nice way we can probably handle this. So, terrain normals array. We create it, then we set the pixels. We copy from each patch to this 3D texture. And we need to apply it as well, so terrain normals array dot apply. So whatever data we have on the CPU, we want it to be applied to the GPU side as well. And then we have set texture terrains data texture simple. Oh, that was the old one, but let's take this one and just do terrain normals array and terrain shader indirect terrain normal texture. Okay, and what we're gonna do here is we're gonna send some data from, I think we're gonna read it in the vertex shader, and then we're gonna send it onwards to the fragment shader. I think that's how we want to do it. Janelle Cosmic, thank you so much for the follow. Appreciate it. So it's also a question of the tangents. We do need the tangents down here as well. Fuck, I don't know, this feels a little bit shaky, but whatever, normal. I think it's normal. World space. I think we're gonna work in world space with normal. Yeah, I actually think we need this as well later on. The question is, do we want to calculate this on the CPU as well, or do we want to... I mean, we could generate fake tangents, I suppose you can call it, using the normal world's normal. I don't know. Let's start with normal world space. So we want to read it very similar to this. Good morning, Harukanan. Hope you had a wonderful weekend. Terrain normal texture. UV instance ID 0 RGB. And then we just do output dot normal world space is equal to normal world space. And instead of coloring this with the color, we're gonna do it, or we're gonna use the normal with an alpha of 1. Was all right, I guess. Still sounds pretty good. Yeah, mine was nice as well. Traveled back to my hometown to celebrate my sister's kid's birthday. It was very nice. Okay. Yeah, so let's see what kind of result we get here, if we do get any normals or whatever happens. Yeah, one thing. What the oh, yeah. So at the edges we have normals of 0. That's why it looks a bit like this. Oh, these textures are beautiful. We can work a lot with these. And this is the naive approach. But one thing that one might notice instantly is the color scheme here. It doesn't exactly look like normals. And when we read from the texture here, the normals are in a 0 to 1 interval, or 0 to 1 range. We want to change it to -1 and 1, and that's just done by doing multiplied by 2 minus 1. Yeah. But do I want to do it here? Let's just do it like this. But then I don't want to call this one. Let's see. Normal world space 0, 1. Yeah, I think I wonder. Yeah, we want to start with we want to add the up normals as well. So right now we basically just have right or left, forward or back. But it looks, I love the scale here. Here is our little character. Do we need to normalize it? I think we normalize it on the CPU. The question is, do we need to normalize it here as well? Yeah, we might get, I don't know how much of a difference we will get from this. And I also wonder, I also wonder yeah, I think we want to do this. Terrain base, no, terrain patch indirect. 0.0 here. I think we're gonna do 1.0 for the Y. So this is still the naive approach for the normals, but should be more correct now than previously, at least. Or is it? This is way off. What the fuck? Okay, I get this. That's just plain wrong. What's up, Cooler SK? Yes, indeed. Hope you had a nice weekend. Yeah, do we want to do this? Left. Yeah, maybe we want to make it a little bit less naive. So... Or do we? And J. So I guess we want to do this. Okay. Okay, so something like this, and then we do vector 3 normal naive is equal to cross left right cross between left minus right and up minus down, I think, and then we normalize, and then when we pack it we also need to do minus or multiplied by 0.5 minus 0.5. I thought times we can multiply it, but we can't do minus, so vector 3 1. Maybe this order is wrong, but we'll see. Hopefully we'll get a better result than this anyway. Or not. left minus right, which means point on left. Yeah, I wonder if we want to... The order of these... I know that the order of these can screw it up, but I wonder if it can screw it up this much. And actually... Did I... Yeah, this is not what we want to do. We want to do... So this is between 0... minus 1 and 1. We want to multiply it by 0.5, but we want to add 0.5 to make it between... So from minus 1 to 1, we want to make it from 0 to 1. How? Oh, yes. We don't want delta here. We want... Jesus. 1. So the indices needs to be integer because we're actually reading a texture here. Okay, this should hopefully solve it. Okay. Could it be, could it be, could it be? When we read height here. Yeah, we might want to do... Get pixel... I don't know. So like when we use delta here, it's actually world distance between its neighboring pixels. When we read height, we took the value directly from the texture, which is between 0 and 1, and we need it to be world. Okay, this is better. I like this a bit more. But still, is this the normals we're supposed to get? I would want to see more green affecting this. It's weird. Like here, for instance, that we're actually getting black here instead of green. That's not correct. I don't think. No, definitely not. And if we switch this one back, okay. Now it's green at least. Fuck, I want to see what we get if we do... I could have changed this. If we don't do this... So we just output values between 0 and 1. Okay, I like this. I like this. I think. So blue, but it's... Fuck it, let's do... Do I have... I thought I had... shader... Fuck, I had one shader here. View normals, vertex, color, alpha. No. Okay, let's do... Yeah, let's do one of these again. But let's... I wonder why I removed it. So I want a shader that just outputs the normal color. It's very nice to have. Very handy. Debug shaders. World normal shader. Let's do normal world space. No, object space. And I also want tangent. Pretty sure I don't want this. And here we basically want to do yeah, I want one of these. Let's see here. Let's worry about that soon. UV vertex. Let's skip these. This one. And position, clip space. What is it called? Cell shade lit. It's called vertex position inputs. Vertex. I need to remember this one. Vertex position inputs. Vertex input. Yeah. Let's do both of these. Position CS. I think it should still be float 4 here. Okay. Line 42, unexpected token, a dot. Oh, yeah. Return in float 4 input dot normal in world space. But this one is between -1 and 1, so for now we're just gonna do times 0.5 plus 0.5. And let's create a debug materials as well. Okay, and let's keep this material this time. Oh, we want one thing here. Unlit world. Let's do debug. Yeah. Okay, and yeah, this looks nice. It looks... I'm a little bit afraid that we're not really getting this result here. Oh yeah, he's in the sphere. Whatever. Maybe. Actually, this has to be wrong, right? It looks pretty good if you compare to this one. Although I don't know what's going on here. I wonder... Okay. Yeah, this just feels a little bit too bright to me, but maybe. What's up, Jokoho? Yeah. These colors looks pretty spot on, these two, but maybe it is correct. What are you struggling with? Right now we're trying to like recalculate normals for terrain generated by a height map, and I'm mostly just wondering if we have the correct normal values here before we continue on. I would say it looks quite okay. I wonder if maybe we should do, let's see here. Can I do this in an easy way? Yes, I can. Let's do, yes, we can. Let's do this. Garden indirect, let's remove these height maps, and then we have, let's see, garden, and 2000, 2000. Two thousand, 100. Yeah, that should be it. Yo, what's up, Calvino? Welcome back from vacation. Hope you had a wonderful honeymoon, right? I'm good. We have moved on from grass to terrain generation, and I don't know, we've been doing it for a week, I think, and it's going pretty good. Pretty good. So we have one approach here that is we generate and build everything on the CPU. Now we have a second approach where we try to offload a few things to the GPU, and that's where we're at. Although I wonder why my beautiful terrain didn't generate this time around. Terrain base. Oh, I know why it didn't generate, because we didn't ask it. So let's do regenerate on garden. Sounds cool. Did the grass turn out well? Yeah, pretty good. I might show it later on again. But like, it's in an acceptable state. Let's put it that way. Okay, here we have our terrain. And yeah, my honeymoon was fantastic, and the trip was better than my expectations. Nice. You love to hear it. Okay, here we go. This is pretty rough normal generation here actually. I think what fucks it up a lot is the max height, so we're gonna go with 10 and we're gonna regenerate it again. We do know that Garden, like if the CPU based solution, this one works well. This one gives the correct result. So it gives Unity, similar result. Jesus. Or at least it did. Is this the normals you want to see? Why did you decide to generate the terrain yourself? Do you plan to implement also LOD levels? Jokoho, don't you know me? I do love to reinvent the wheel, man. I decided to implement, like, I draw the pros and cons, and doing the terrain myself had the most pros. I'm gonna need, like, terraforming is gonna be an extremely big part of this game. So you want it to run, like I want full control over what I can do, and you want it to run, you want real-time terraforming pretty much. And I do believe in myself that I can manage it. But, oh but. I'm a little bit worried about this normal generation we're seeing here. Maybe. We can do it like this. Okay, let's do Garden 100. And then we do... terrain patch. Instead of doing this, we just do yeah, you want normals that are, when we output them to the screen, we want normals represented by 0 to 1 and not -1 and 1, right? So that's what you're seeing here. So these are normals generated by Unity, and that's pretty much what we have. Let's do, wait, one sec. Yeah, we wanna regenerate it. So yeah, since we have like put them through a range change, we pretty much have pushed them through a post-processing filter. It could be seen like that. Okay, so these are Unity generated normals for this terrain. And like the artifacts we're seeing here, this blocky artifact, is because the height map resolution is only 64 times 64, and we use a very big mesh to visualize it. But it's nice to have this. So this is Unity based normals. Now let's go to our indirect solution, and we have this exact same setup here, but we generate the normals ourselves in a naive approach. And the question is, do we get a similar result or not? we don't. So I do wonder if it's actually we need to change the terrain data texture as well. Okay. We get way brighter colors than the Unity approach. And I wonder, is this only because of the naive approach compared to their approach? I'm not sure. Actually, we don't even get the same, do we? We're seeing a higher value here. There's quite a difference actually. So here we go from Garden, we go from 0.01 to 100. In Garden Indirect we go 0 to 01 to 100. Why are we seeing such a big difference in height? We set height range here. Do we use this one? Yeah, we don't use that one. Okay. Here we do set float, max height, height range, max. So we should have the correct values here. Max height times height value. Why are we seeing such a big difference? Height, is it this one we use? Height, get index wrapped, yes it is. Height, terrain data, height. Oh yeah, it's a terrain data container. Height will lerp between X and Y, so yeah. Or no, we lerp between this range, so it should be okay. Other than the apparent height difference here, it looks to be roughly the same, right? Pretty sure this shouldn't have anything to do with it. Okay, so two problems. The instance-based approach yields way more distinct normals, and we seem to be like it's located a little bit lower. What is it? 100 times 100 lower than the other one. It's very weird, and I don't know why. So let's see here. Yeah, I'm pretty sure it's the graphic card based or the instanced terrain we have that is closer to the correct result, if not the correct result. Very interested in why this one becomes so much higher up. Height, we do height range lerp. Value, so I see get pixels. We read a pixel. This is a value between 0 and 1, and then we lerp it by the height range. Yeah, nothing wrong there. No. let's see, terrain patch. We create a new position. Could it be that position is off? I don't think it should be. Nope. Ooh, but although, let's see here, terrain base. Position 0 here as well. Oh yeah, okay, 0 here, but I wonder if terrain patch, when we generate the vertex here, we do terrain data height. Should be okay. The fuck? Now we literally just take the height from the terrain data. That's all we do. And I don't see terrain base indirect. We set max height. Max height. Okay, let's do this as well. I just want to double check. So the idea is that both of these terrains should be generated with a height range of 0 minimum, 100 maximum. Both of them have this height range. Although, yeah, they use the same height map as well. This sphere is 200 times 200. If it were 100... So this is a radius of 100. So yeah, it's probably... Yeah, the CPU-based terrain gets generated... Fuck. Cube 50... 100... I don't even know where to begin. So, okay, the Y here is... There we go. Is it actually the... Yeah, it's probably the the instanced terrain that is not being generated accordingly. Because this one have a height of 100 now. And this one is closest to it at least. Or is it... I never know. A cube, a default Unity cube, is it 1 times 1 meters? It's... yeah. Pretty sure. Okay, so terrain shader indirect, why don't you generate properly? Doesn't max height get transferred correctly? Maybe not. Let's take a look. But it should, I think. We can affect the garden indirect at least. So a height of 1000. Seems to work as intended. Could it be? Could it be? When we create this one, we do false, false. Let's see. Terrain patch. I wonder if... when we create a texture here, we do... let's see here. No, we do linear here as well. Although, yeah, we don't do linear here. That's so when we create the texture 2D, the last one we want it to be linear. I mentioned it earlier today. Unfortunately, I said false instead of true here for some reason. Okay, so let's fix it here. This will probably have affected the result a tiny bit. We want to do it with this one as well, actually. Okay, let's just copy this. So instead of we send in a texture 2D here, we want to create our own because we want a linear color space. So we're gonna do this dot terrain data texture is equal to new. Just gonna copy this one. And then we do temp. I think it's like this we want to do it. Maybe not the prettiest way, but yeah, whatever. And then we delete this one. So we create a new texture 2D with these settings, and then we take whatever data is in this one and we add it to the one we create. Although, yeah. The most important part, however, is that this one is true. We want them to be linear, so I guess we also need to fix that in terrain base indirect when we create terrain arrays here. We want to set this one to true. Okay, let's see how much we screwed up. And if we compare to garden, do we still have any difference? We probably okay, that's better. That's way better. Okay, normal's still off, but height is the same now. Okay, great. These colors are a bit more distinct. I wonder if that's because of the... it feels weird. I don't know, like, if something is wrong with the approach, and that's why we're seeing much more distinct colors on this normal generation compared to this one. Or if this is just a result of the different approaches to calculating the normals. So let's add let's try and generate these normals using the other approach, or the same approach as Unity uses. Let's see what kind of normals we get with that. So on the GPU, then we need max height and we need delta. We have both of those, and then we want to do, so we pretty much want to implement this algorithm on the CPU, but not the scaling here. So we want to save the scaling. I wonder... Whoa. I'm not entirely sure this is correct right now, actually. I think we need to which means that we should see well, let's implement this one in terrain. What is it? Terrain patch indirect. Let's copy this. Actually, we have something very similar here. So we're gonna do this. So yeah, let's take this one. Recalculate normals naive and calculate normals connected neighbors. So and not return here, but new vector, and we want to do, I want to wait a bit with this one. So get terrain patch, height, and so on. We're gonna simplify this a bit. We're just gonna do height, and we don't care about index wrapped. We're just gonna do this. But then again, when we get to height like this, I think never mind. Okay, so we get the height for all connected neighbors. And basically what we do is we do up cross product right plus cross product right down. Yeah, we do 6 cross products, but it can pretty much be simplified to this. Although I wonder, let's see here. So we want to do vector 3 normal is equal to this one, but we also want to do, we normalize it, and then we do, so then it's between -1 and 1 once again, so multiply it by 0.5 and add 0.5. And then we do but okay, so I think this is partly wrong. We actually need to do I think it's supposed to be like this, actually. Pretty sure. Okay. So instead of using this one, where do we use this one, by the way? Yeah, we do it here. So for each terrain patch indirect, we do recalculate normals naive. Let's do. Okay, did I set it to private? Okay, let's go. Public. Okay, let's see what kind of result we get with this. Hopefully, exactly the same as Unity's, like with our garden. But we might even get it. It might even be a little bit smoother because right in this case we're doing. Let's see here. Is it? Yeah, maybe. Because we actually calculate the normals, then we save it to a very small texture. So, yeah, let's see. Pretty much exactly the same, right? A little bit shocked by this. And world normal shader we do Should be okay. I do wonder though why we get... Oh, 1 sec. Yeah, of course. Never mind. Let's see. Terrain patch. Yeah, we do mesh.recalculate normals. We don't use those, right? I just find it extreme, like these normals doesn't look... It's probably something like this we want to achieve. Delta, do we have the correct delta here? Dimension divided by resolution. Although still a little bit worried about this one. Let's see. So, just to be clear, the difference here is terrain patch. We calculate the normals on the CPU and then we send all that data to the GPU. So the data actually gets the normals like this. So per vertex we have a normal in object space. That is the terrain patch solution. And right now we do use recalculated normals like this. Compare this to terrain patch indirect. What we do here is we calculate a normal like this, and we pack that normal into a texture. In the shader then we have to read that texture and then we output it. Like, there's a lot that could go wrong during all this. To normalize here, I think it's okay. We do normalize here as well, but actually, Hero Sodomy, thank you so much for follow, appreciate it. Oh, I wanna terrain patch. And if we use our solution here, so we can do this. We comment this one out, recalculate normals. We use our solution instead. So normals is equal to normals. We populate this here, calculate from height. And I just want to fix this one real quick as well. So let's see what this yields. And then we're gonna have to regenerate this, and we actually generate 2k times 2k vertices, so it's gonna take a couple of seconds, but whatever. So let's do garden. And regenerate. Let's see what we get. What I want to see here is the exact same result. We shouldn't see any difference. And that's what we get. We get the exact same result. So we do know that this is the approach that Unity uses. And we right now. So we get the correct result for when everything is done on the CPU, when we don't pack it into a normal texture. But if we pack it into a normal texture, that's when things get screwed up. Very interested in, like, there's so many things this can be. But it could be somewhere around here as well. Delta might not be calculated correctly. Height. XY, data height range max. So this should be correct, I think. Delta here is dimension divided by resolution. Terrain patch, delta. Dimension divided by resolution. Here it's dimension and resolution are subdivided. I think that's the case for terrain base indirect as well. Resolution subdivided, dimension subdivided, and that is what we send in here. So terrain patch indirect, the delta should be correct as well. Galaxy, do you know about Llama and Lim models? No, I don't. No, I don't. What are those? AI stuff. We're doing custom terrain generation here. AI stuff, yeah, appreciate it, Harukan. Okay, so why? Okay, so it's not the delta. Left, we pretty much copied all of this from the one that we're working. So I want to say this. Galaxy, you're creating a game. Yes, that is what we're doing in the long run. We're creating a game, and like specifically short term, we're creating some terrain that we can hopefully terraform in our game. You just yeah, that is unfortunately the case for most projects, I would say. Like 99, let's just put it like a majority of projects get cancelled or abandoned. But I think I've always found terrain generation extremely interesting, so I'm like happy to do this and learn more about it. Yeah, it is indeed. I don't see how anything here could be wrong. This gives us a normal between -1 and 1. We multiply it by 0.5, so this gives us a normal between 0 and 1, so we can pack it up nicely into this texture. In the shader, once again, we just read it and output it. It has to be terrain normal texture. I don't see where else it would be. Let's see. Terrain normal texture. Do we want to texture format? Nah, it should be okay. I do know that Unity likes to store them in a different format than, but if we do RGBA float and we do no MIP chain and it's linear, we should be able to store it like this as well. So I don't see this one being wrong either. When we create the terrain normals array, we do RGBA 32. Do we use a different fuck it, let's do RGBA 32 for both of them, because we use that here, and we also set the pixels correctly. Yeah, I don't see it being here. Nowadays I'm working on a web developer AI, created a web scrape, and after that I gotta collect that and train it. Sounds nice, interesting stuff as well, and thank you for the follow, appreciate it. You're doing the game all alone? Yeah, right now I am. We'll see if that's the case in the future. Okay, let's hide this garden. Let's play again, see if we have any difference now. The only thing we have changed is the specifics of the texture format we use. And unfortunately, it doesn't seem to be the reason. Okay, so it still looks like it did. Although we now have red borders here, maybe that's okay. Does it look better? I don't get it. Like these normals are it feels like the normals we're getting here are tilted too much. We should see more of an up value, I think. That's the problem we're having. So actually we don't need to send in max height and delta to the shader. Maybe in the future though, but that's okay. We don't use it here. Max height we do need to send in, but we don't need to use it for the normal calculations, neither the delta. Why Love Day, thank you so much for the follow. Okay, I'm thinking about and it is, let's see here, terrain base, world normal shader. Yeah, so we're working with normal world space here as well. We show it between 0 and 1. Oh, one sec. Okay, fuck it, I know it. I think I know it. I hope I know it. So... I think so. Let's see. Terrain patch indirect. When we generate the normals here, we're generating them in object space. We save them to the texture. I think so. It's an object space. So the question is, if we do, let's try it. Terrain shader indirect. Are we in play mode? Yes, we are. Let's see here. So under this assumption, when we read the normal here, it's actually not world space. It's actually object space, and we want to send it as world space. Oh, it's in between 0 and 1. Okay, just to make sure, let's do normal object space RGB times 2 minus 1. So we transfer it in object space between -1 and 1. What up, Red Sun? How are you doing? Long time no see, right? Or, I don't know. I lost track of time. Don't we all sometimes? Don't we all? Okay, so now let's continue with this assumption. I do hope this is right. So this is actually normal in object space. So when we send it here, normal world space, we want to do a object to world. Yeah, we pretty much just want to do this. Oof. What is the rule with the fourth coordinate here? Let's do mul object to world, and we do float for normal OS 0101. Let's see here. Object to world unity fourth coordinate. Is it something? Let's try with one. Let's see what we get. Okay, this is definitely not correct. is definitely not correct. What are you trying to do right now? We're doing custom terrain. More specifically, normal generation. And we have got it working on the CPU, so a very naive implementation of terrain generation. And now we're trying to move most of the functionality to the GPU, so generate the height and normals on the GPU. Or that's not entirely true, but sort of. Oh, but maybe. Let's go with 0 here, and then we do times 0.5 plus 0.5. So, we sample the texture, we get the normal in object space, but we do get the normal value between 0 and 1, so we multiply by 2 and subtract 1 to get it between -1 and 1. Then we multiply with the object to world matrix, which means that we will hopefully get this normal from object space to world space. Then we just send it onwards. So then in the fragment shader, we read this normal in world space. It's between -1 and 1, but we want to represent it as a color that we can see basically. So we change it back to be between 0 and 1. And we get something like this, which is totally wrong. What's up, Shivam? Yeah. Fucking hell, man. I'm a little bit worried about the tuple fee here. Object to world unity, built-in shader variables, current model matrix. Yeah. Yes, object to world. Ooh. Yeah, we might screw up the normals here because we might translate them as well. I don't know if this is the problem. Shivam, I'm also interested in coding, but I don't know where to start my journey. Wow, that's a hard question. What do you want to do with coding? What do you want to create? I guess the first question you should ask yourself. Okay, games. One sec here. I don't know if you've heard about the streamer called Pirate Software or Thor, but he has a very nice website if you want to get started with game development. Or so I've heard. Yeah, one sec, I'm trying to find the link. The correct link. I think the best way is probably to join his Discord, and there he has a lot of links if you want to get started in game development. I've only heard good things. Okay, so object to world, this matrix we have here, it's a translation matrix. That's pretty much all it is. No problem, and good luck, good luck. And we don't really want to translate our normals. I really thought this could be it. Let's see. Current model matrix. Ooh, this is actually really good. I think we are... yeah, we're gonna have to rely on these later on. I'm a little bit worried about this one. Okay, that's unfortunate. This was not the solution to our problem. Let's see here. Unity, transform, normal from object to world. Yeah. Exactly. Yeah, so this one is very important. I thought I remembered something like it. Hmm. Okay, let's see. Normalize world to object XYZ plus Okay, I want to try this then. World to object. Oh. Oh, yeah. So we need to the inverse if that's the case. Yeah, but if it's just a problem of and to be honest, we're not rotating, we're not scaling, we're only translating. So normal in world and normal in object space really shouldn't be any difference. So this is probably not the cause of our issue. Although I am a little bit we do get a bit, that's like a different result here. So something is happening. Okay. What if we do normalize here? That shouldn't really be any difference. Like I'm a little bit okay. If we compare this one, let's jump to the code and we do. Let's add a float 3 normal OS here and a normal. Let that one be 0 and this one is 1. So we have normal in object space, normal in world space, and right now we're going to set normal in world space will be this one. So we read it, change it to -1 and 1, and then we transform it. But I also want to do output dot normal in object space is just normal OS. Actually, Mul RGB. There we go. And let's do return float for input.normal object space. Oh yeah, we want to do 0.5 plus 0.5. Okay. So this is the normals in object space then, compared to our normals in world space. There's really no difference. A little bit more faded on this one. I wonder why. Yeah, it's because the normalize. So if we do normalize here as well, normalize. So this is in object space and this in world space. Yeah. Okay, since we don't do any rotation or scale, they should be the same. So yeah, I might have taken out the victory beforehand. Okay, so that is unfortunately not the cause of our result. So what is? What is? Store normals in texture 2D Unity. Yeah. Mm-hmm. Okay, so when we recalculate the normals, we do it I don't get it. I don't get it. Although, no, it should be okay. Or terrain shader indirect. I'm just trying to figure out what I can do. I want to like debug this in some way, and I just need to figure out how. I've been thinking about maybe when we generate the normals, although we do generate them the exact same way, maybe we want to save it to a texture we can actually open up and look within. So I wonder if we want to create a render texture here, a render texture reference, which we set in the editor, and then we can see whatever happens to it. Or some other approach. To this conversation, let's see here, normal OS. Yeah, okay, so this I find weird as well. Let's see, normal OS. We just read it from the texture. We send it onward as is. But here we transfer it to world space, and we do it by first multiplying it by 2, then subtracting 1, bring it down to -1 and 1, and then we send it onwards. And here we normalize it and bring it back to 0 and 1. But this conversion back and forth seem to screw it up quite a bit, right? So this is our normals in world space, normals in object space. What the hell? Okay. terrain. Although, let's see here, terrain patch. Height. And yeah, the height here is not the raw value. No, it's not. We had the same problem with the naive solution here. It was like it seemed to give the correct number or the correct normal-ish, but very distinct color, not as washed out as this. And if we take a look at world normal shader, compared to terrain shader indirect, it's the same. Would like to try this method here. It's crazy. It's should be extremely straightforward, but somewhere we have some issue. Probably has to do with this one. Or is it the calculation of delta here? Terrain patch indirect. Dimension divided by resolution. Should be correct. Should be. We do calculate a delta here, but we don't use it. Or do we? That's the one we send in here, okay. But it's dimension subdivided, resolution subdivided, and that's the same we create this one with, so it's the same we use here. Should be okay. Why, oh why? I'm trying to think if... Ooh. Ooh, okay. Like when we calculate the normals for this one, we do it per vertex. So we do it per vertex, so the delta is based on distance between vertices. Now we do it per pixel. Is that so? Oof, let's see. Yeah. Yes, okay, this delta is probably wrong. Oof, I hope this is it. Let's see. We use the same delta here. So the delta should instead be probably dimension divided by, not resolution, but new, let's try this. Vector 2 int terrain data texture dot width terrain data texture dot height. Because here we loop through, we do this per pixel in the texture, while in terrain patch here we do this per vertex. So the delta here should be different. I do hope this is it. Everything else should be okay as is. I don't know. I'm trying to... Maybe. Should get a different result at least. Closer to the correct result, but no cigar. Right? Definitely better. I just wonder why. These normals look pretty damn good actually. But it's pretty damn sure this is one of the issues. I wonder why. Okay, now we use this delta, which we calculate here. Dimension. I just want to see what happens if, let's unpause this, let's take our garden here. So the texture is 64 times 64. Let's take 2000 resolution. How many? Subdivision of 2. Let's see here. So I think I want 64 times 4, 256, resolution 256, 256. So if we generate the terrain like this, we should have a dimension of 2000 times 2000. We should have a resolution of 256, 256. But we have a subdivision of 2, which is basically we have 4 times 4 patches, so each patch should be 64. So if we do it like this, the delta, dimension divided by resolution, should be the same as we have for our garden indirect, I think. Looks a little bit smoother, but still not the same normals. I don't think. Okay. What's up, Tough Eye? Oh, Jesus, why? Okay, so let's continue with the assumption that let's continue under the assumption that the delta is probably not correct. What should be done to make it fully correct? So what are you doing? We're trying to generate we're trying to generate terrain with correct normals. That's pretty much what we're doing. You're one of the only person who pronounced my username correctly. Nice. Yeah, but we're pretty much stuck. The normal generation differs a bit. So we have one terrain solution that is basically most of it is done on the CPU, and we have one terrain solution where we want to rely on the GPU more, and like we want to get the same result between those two, but unfortunately we're not getting it right now. And delta terrain data texture, I think so if we compare to terrain patch again, and now we have delta here is 64. They should have the same delta, but still doesn't get the correct result. Two to the power of 2, 4. We divide by 4, 2, 5, 6. Yeah, we should have the correct values, the correct deltas. don't I have the parent? Oh, I don't even have the parent. Let's see if this one has it then. There we go. There's quite a big difference here. I don't know. Looks like all of these colors are like you want to add like a half to each of the channels. Why would that be the case? Terrain shader. Yeah, maybe a bit too much. still. Actually, I think it's probably the scale of the Y direction that is the cause of it. Normalize. Yeah, we want to do it before we normalize. I just want to try some different values here, see what we get. What the fuck? It's extremely weird. Okay, I might be going insane, but let's try this. Terrain patch, we generate the normals like this, and let's see if we can pack this into a texture as well. Is this what I want to do? Resolution is 64 times 64. But we also do... Okay, let's do this. Delta, delta, delta. Terrain base indirect. Let's do. I know we tried this previously when we were working on the CPU, but let's do test flags. Let's do delta multiplier. I just want to see what kind of difference we get if we... This one we don't use, but we add it here. So, bigger value of delta multiplier basically means that each vertex is further away from the other one. Smaller value closer. And if we have 10, so we have further distance, we should see a more green result, I think. Yeah. But it's still like way too dark. And if we have a smaller value, 0.1, less green. But I don't know. And I've checked this multiple times, but we are using terrain, normal texture, new texture 2D. We do linear true, yes. And the same goes for the texture array, linear true. Okay, so it's actually not only the delta. The delta might very well be okay. Okay. What the fuck? Do love this though. Do love it. So now with the updated delta values. Oh, is this actually? I don't get it. Okay, so we read the value and then we multiply object, we bring it from object space to world space. But we transfer him to -1 and 1 first. Then multiply to world, then normalize, and now we have normal in world space. And that one works. What I don't get though is What I don't get is that our object world is pretty much just a translation matrix. Like, what actually happens to the normals? What makes this work? Wait one sec. 2 minus 1 times 0.5 plus 0.5. Fuck yeah. Okay, so let's see here. Terrain patch indirect. The problem was actually the delta here. So we were working with values that were way smaller than they should. So we were working with, I think, yeah, we were working with delta values that were much smaller than they should be, which means that these slopes, the slopes got way more, what the fuck's the word for it? One sec. Steep. Okay, so this, like, values, smaller distance between neighbor points made our slopes be way steeper than they actually were. That's why we got less green or bright color and more towards blue/red. So if we take this sphere here, we were located more on this side, but like basing the delta on the actual texture resolution means that we make the distance, the delta became much bigger and we got the correct normals. Although in the terrain shader indirect, the normal here, we still had a little bit of an issue here with the conversion between -1 and 1 and so on, which means that we didn't get the result we anticipated instantly, which was a little bit sad, but okay. So nice. Feels wonderful to have gotten to the bottom of that before I had to end this stream. It means that we can do a lot more fun stuff tomorrow. But delta, extremely important here. Great, and now it should work as well if we pause this one and we do garden, bring this one up to 2000 again, regenerate. And okay. Now we get these artifacts, but that's true. Like we generate this terrain, a very high resolution terrain with 2000 times, or it's 500 times 500 vertices, but the textures we use to generate the terrain is only 64 times 64, and which means that like this result is actually better. It's more smoothed out. That's beautiful. Although we do have to fix the seams on this one, but other than that, great. Correct normals, I'm happy. What's up, Fabic? Have I forgot how one opens up? Not the best timing, Fabic. I'm just about to quit this, but you didn't miss much. We've been fighting with getting the normal to generate correctly for the instanced terrains, and pretty much just managed to do it. Very nice. Seams are left, but I think we're gonna do that tomorrow, and I think it will be quite... We're gonna fix the seams on the texture side of things, so we're actually gonna compare textures, the borders of textures, and readjust them so that the borders of the textures are always the same. And I think, yeah, well, the question is, will that result in some weird behavior? It should be okay, but like, unfortunately I have to run now, but it feels wonderful that these normals got in place before I had to end the stream. We'll continue this tomorrow, hopefully with less obstacles that take this much time to solve. But so yes, thank you so much everybody for watching as always, and have a great rest of the day. Peace.